All right, the big little principle. This is a really, really basic idea. Just these two basic rules that kind of help you see what something is going to approach. So we got something, if you got some number or one or some constant really over a number that's getting infinitely large, right? Infinitely large. Okay, we're not just saying like 100 or 1,000 or a million. We're saying infinitely large. Well, what's going to happen is that this number is going to approach 0. It's going to get smaller and smaller and smaller until finally it approaches 0. So you could think about that by just kind of a few examples. 1 over 100, that's 0.01, right? And what if you did like 1 over 10,000? Well, now that's 0.0001, and so on and so on and so on. Right, and so you can see that the bigger this number gets, we could even do like 1 over a million, and that would be 0.000001. I think I did that right. You could see the pattern here, right? The bigger this number gets, as it gets infinitely large, the whole thing is going to get infinitely small. And eventually we're saying that when this is actually gets to infinity, or infinitely large, then this actually will equal 0. In the same way, if this number gets infinitely small, if this denominator gets infinitely small, then this number is going to get really, really big. So you could try it like this. What about 1 over 0.1, or 1 over 0.01, or 1 over 0.001, right? You could start seeing what happens. This is going to be 10, this is going to be 100, this is going to be 1,000, and so we can see that the smaller the denominator gets, and when I say small, I mean infinitely small, I mean less than 1, really close to 0, so the smaller this denominator gets underneath some constant, then this is going to approach infinity, because this is getting bigger and bigger. Because you can think about it, you can fit this number into this constant more times, right? The smaller it is, the more times you can fit it in there, and that's essentially what we're doing when we're dividing. So yeah, when this thing gets infinitely small, we're going to get infinitely large here. So that's the basic concept. So 1 over something big is going to approach 0. 1 over something small is going to approach infinity. That's kind of really all there is to it. So let's take a look at this thing. And let's just think about what this would be, right? And just go ahead and let's just plug in a 0. What would it be? It'd be 1 over something infinitely small. As you got closer and closer to 0, this would become infinitely small. So really what we're dealing with here is you're just dealing with 1 over something really small. You don't have to write 1 over something small. But we already know what that's going to be because we've already said we've already seen that pattern before. When you divide a constant by something infinitely small, it approaches infinity. And so there you go. And that's all there is to it. It's going to approach infinity. Now, you could go ahead and plug this in, and evaluate it. Plug in like a -1, -0.1, -0.01, and so on and so on and so on. But you'd see it's going to become infinity. It is important to kind of think about both sides of this. For this one, as you approach from the negative and the positive, for both values you get a positive on the bottom, and so this whole thing is positive, so we are approaching positive infinity. But it is possible to get a limit that is not approaching the same infinity. One can approach positive infinity and one can approach negative infinity. So I'll show you an example of that in the next one. So let's look at example B here. It says try to plug in some points here, and we'll play with that. But really all we're going to do is we're just going to kind of evaluate these limits, and we're going to start off by just kind of graphing it. So it's just 1 over x, and let's just take a look at what that would look like. Let's think about some values. Well, I'm gonna just make this -1. I'm gonna make this 1, so we can kind of get a good idea of what this looks like. Right. So 1 divided by 1 would just be 1. So we'd have a point there, and we'll just do the positive side for now. We'll just evaluate over here, then I'll do the negative next. But what about 2 divided by 1? Well, that would be a half, right? So that'd be going down here, and we can kind of see there might be some curve here. Let's go this way. What's 1 divided by a half? Well, 1 divided by a half, you could do it real quick. 1 divided by a half is the same thing as 1 times 2 over 1. So you get 2. And you could start to see a pattern here. What about like right here when you get to like 0.01? Well, we already did this, right? 1 divided by 0.01 is like saying 1 times 100, and so you get something really, really big. It's way, way up here. I can't even really graph it. It's going to be so far up there. So we can see really quickly what's happening here. It's shooting pretty much straight up. Oops, sorry, I missed my point. So it's shooting pretty much straight up. My graph looks ugly. Okay, so we can see that as we approach 0 from the right, we're going up to positive infinity. So let's just go over here. That's this one, and so we can say, yeah, that's approaching positive infinity. Okay, let's do the left side now. Okay, well, 1 divided by -1 is just -1. So there we go. And the same thing, 1 divided by -2 would be -1/2. And so we get something like this. And so we could start seeing a similar pattern here. What about something like -0.01? Well, again, 1 divided by -0.01 is the same thing as 1 times 100, but it's like -100, so it'd be 1 times -100, so it'd be -100, it'd be way down in here. I can't even graph it. And so we could start to see there. And so we can see that this graph is going to start approaching negative infinity at 0. So what is the limit as 1 approaches x? Well, it doesn't really exist, right? We can tell it's going to approach infinity because it'd be 1 over something small, but see, one side is approaching positive infinity and one side is approaching negative infinity. So the limit doesn't really exist, and even if it was approaching infinity, it's still not a real number, so it's not fair to say that an infinite limit exists, but it is something that it's some way that we can describe it still better than just saying it doesn't exist. So if you get that these are both positive infinity or these are both negative infinity, you could say the limit is positive or negative, even though infinity is not even a real number. So, and you could try plugging in even smaller values and see what you get, but you're just going to get really, 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 I guess, small, or I guess, I don't know, big negative numbers or really, really big positive numbers the closer and closer you get to 0. So that's it for this video. See you guys on the next one.